No. What I wanted to ask you was exactly what is this? Does this have anything to do with statistics?
Um, certain, there's something in it that has little to do with statistics. But binomial theorem, the basic binomial theorem that I learned is just a method for expanding a polynomial without having to multiply everything out by hand. And
What's a polynomial?
like x plus y quantity raised to the n power, being able to expand that out, whatever n may be, without having to multiply it out. Like x plus y squared without binomial theorem, and if you don't know, just know the answer off the top of your head, then you have to actually write out x plus y times x plus y, and then multiply the outside variables, and x times x is x squared, and then multiply these outside ones, so xy, and then multiply the inside one, xy again, then multiply the last variable, so y squared, then x plus xy is just 2xy plus y squared.
So that's, what's that called? Orders of operation, right?
Yeah, you have to follow orders of operation if you want to do this correctly.
Okay, what are the orders of operation?
Well,
You do
for
what's...
this one, for the basic arithmetic orders of operation is, you're supposed to remember it with the mnemonic that's please excuse my dear Aunt Sally, and P stands for parentheses, so anything in parentheses you do that first, and then the excuse, the E is for exponents, which is like when you raise something to a power,
Okay.
and then M is for multiplication, D is for division, but that doesn't mean multiplication comes before division. Multiplication and division both come before addition and subtraction.
Okay.
I'll just write that down. And this is just multiplication and division, and this is addition and subtraction.
Okay.
So it's parentheses, exponents, and then multiplication and division, and then addition and subtraction. But this is sort of different from that. This is when you're multiplying two quantities, you can't just say like x plus y quantity squared does not equal x squared plus y squared. That's mathematically incorrect.
Mm-hmm.
You have to write them out, and then you do the first, the outside, the inside, and then the last.
Okay. Because what you just wrote would be a violation of the order of operations. X plus y squared is not x squared plus y squared.
Yeah. Well, that's really more just one of the identities, one of the arithmetic identities than order of operation.
Okay. Okay, so go ahead and do what you were doing.
And so, binomial theorem is to do stuff like this easily. Like for instance, if x plus y quantity squared is easy, but if I had like x plus y to the 23rd power, if I multiplied it out like this, that would take all day long to do. And the formula for binomial theorem is x plus y to the n power is x to the n minus r, y to the r, and then multiplied by that, which I'll explain in a second, which usually goes out front, I guess. So, and this is for each term, and n n is just whatever exponent you have, and r equals basically the place, the location of the term. So if I were to do x plus y squared and use the theorem, then first term would be that, in which case n is 2, and r, this is the first term, so r is 0. It goes the 0th term in the first term, and the second term in the third term. And so it would be that, and then x to the n minus r, so x to the 2 minus 0, and then y to the r, which is 0, plus the next one. So this time r is 1, x to the 2 minus 1, y to the 1, and then plus, then x to the 2 minus 2, y squared. And then if you do all of this, yeah, I'll just, that is 1, so you end up with x, 2 minus 0 is just 2, so x squared, y to the 0 is 1, plus, and that is 2, x 2 minus 1 is 1, and then y to the 1, and then that is also 1, and 2 minus 2 is 0, and then y squared, so you just end up with y squared. So after you work all of that out, you end up with that, which is what we got up here from multiplying it out. So you can see on a small level that this method works, even though it's actually, when it's just 2, it's easier just to multiply it out. And now this notation is how this is related to, I guess, statistics and probability. This is interchangeable with a different notation, which is this. And this is called a combination. And then the formula for that is just and the exclamation point is called a factorial. And you don't really need to know the formula is, because you can do that with a calculator now. There's a button for that. But just for your information, a factorial is like 5 factorial is 5 times 4 times 3 times 2 times 1. And 10 factorial is 10 times 9 times 7 times 6, etc., etc. You just multiply it by all the preceding numbers. And so that's the formula for that. And so that is what goes as the preceding coefficient. And geez.
So what's that paper there?
This? Yeah, here. And I can demonstrate that again if you want. We'll get into Pascal triangle in a second.
Right.
I need a calculator. Okay. So x plus y cubed. I'll use the binomial theorem first, which I'll write it up here. X plus y to the n equals NCR x to the n minus r y to the r. So first term,
Who invented the binomial theorem?
I think it's Descartes.
Okay.
Um, so first term, r equals 0, n equals 3, always. So 3, 0, x to the 3 minus 0, which is just 3, and then y to the 0, which is just 1, plus 1, x to the 3 minus 1, so x squared, and then y to the 1, and then 3, 2, x to the 3 minus 2, so x to the 1, and then y to the 2, and then 3, 3, x to the 3 minus 3, so x to the 0, which is just 1, and then y to the 3. And so that's the entire expansion using binomial theorem. And then you can use a calculator. 3c0 is just 1, so that's just x cubed. And 3c1 is 3, so 3x squared y. And then 3c2 is 3 also, so 3xy squared. And then 3c3 is 1, so y cubed. So that's the expansion using the formula. And then if you multiply it out, x plus y cubed, let's start with x plus y times x plus y, which we did before. X times x squared, x times y, xy, and then y times x, still xy, and then y times y, it's y squared. And then xy plus xy is 2xy, 2xy plus y squared. And now multiply by the last time to make it cubed. And so multiply x times x squared, x cubed, x times 2xy, 2x squared y, and then x times y squared, xy squared, then y times x squared, x squared y times 2xy, 2xy squared, and then y times y squared is y cubed. And combine the like terms. You have a 2x squared y here and an x squared y here. So add them together and you get 3x squared y. And then you have an xy squared and a 2xy squared, and add those together and you get 3xy squared, and then you have a y cubed left. And you can see that these are the exact same thing. We got to the same place, multiplying it out and just using binomial theorem. This only took 2 lines, and this took a bunch more lines.
Okay.
So that's binomial theorem in a nutshell. And then there's this weird relationship between binomial theorem and Pascal's triangle. I'll make a Pascal's triangle. He just starts with a triangle of 3 ones, and then you continue down the side with ones, and you add the 2 numbers above of each space. And so on and so on. And so that's Pascal's triangle. And what someone, I don't know who, noticed was that the numbers in each of these lines matches up to the coefficients in each expansion.
Show me that again. Where are the coefficients?
Like 1, 3, 3, 1. And then for x squared, where is that? 1, 2, 1. 1, 3, 3, 1, 1, 2, 1.
Okay.
And so that's the relationship between binomial theorem and Pascal's triangle. Like if we did, I guess we can do that. Like the relationship says that these numbers should be the coefficients of x plus y quantity to the 5th power.
Why 5th power?
Because it's, I mean, these are the coefficients of x plus y squared. These are the coefficients of x plus y cubed. These are the coefficients of x plus y to the 4th. And these are the coefficients of x plus y to the 5th. And then the next line will be the coefficients of x plus y to the 6th. And so on and so forth. And so if we do...
What's the coefficient?
Coefficient is just the number that's multiplied by the variables.
Okay.
Like 3x, 3 is the coefficient, and x is the variable. And so that's what's matching here. These are the numbers that are going to be multiplied by the variables. So if we do x plus y to the 5th, expanding that using binomial theorem, you have 5, 0, x to the 5 minus 0, y to the 0, and then 5, 1, x to the 4, y, and 5, 2, x cubed, y squared, and then 5, 3, x to the 2, y 2, and then 5, 4, x, y to the 4, and then y to the 5th. Oh. 5, 5. Y to the 5th. And so if you take the calculator, I see 0, it's 1, anything C0 is 1. You have x to the 5th, then 5C1 is 5, you have 5, x to the 4th y, and 5C2 is 10, 10 x cubed y squared, then 5 C3 is also 10, 10 x squared y cubed, then 5C4 is 5 x y to the 4th, and then 5C5 is 1. So y to the 5th. And so using binomial theorem, we expanded this out to this, and you can see the coefficients are 1, 5, 10, 10, 5, 1, which corresponds to the Pascal's triangle, 1, 5, 10, 10, 5, 1.
Okay. What does that have to do with statistics?
Well, this operation is important for probability, which itself has something to do with statistics.
And can you do something about Avogadro's number? How that works?
Which number?
Avogadro? What was that
Never
number
heard
you
of
were
that.
talking about with Clint that was really interesting?
Phi? The golden ratio?
Maybe that's it.
That number?
Yeah.
Let's see. How did you... What was that? Same number.
You don't remember Avogadro's number?
No.
Hmm.
I mean like Avogadro's number? That's a chemistry thing. That's the number of particles in, that's the number of atoms in 1 mole of a certain element.
Oh. Okay, so what's phi?
Let me see if I remember how to. One 1.618. That's, yeah, that sounds right. 1.618. Well, all I really know about phi is that it's supposed to be the most aesthetically pleasing ratio to humans, and a lot of architects built things with phi in it.
I thought it appeared in natural
Yeah, it
ratios
does.
too.
It appears a lot in nature, and no one's really sure, you know, why it's so special. It's just supposed to be like the perfect ratio. Called the golden ratio, or phi. It's about 1.618. And the way Clint derived it was, it's the only number known to math that is the same multiplied by itself as it is added to 1. So he set up this equation, x squared equals x plus 1. And then he told me to solve it. And so x squared, and then you just move this over here. Negative x minus 1 equals 0. That's a quadratic equation. And you solve that using the quadratic formula, which is x equals 1 plus or minus the square root of 1 minus 4 times 1 times negative 1. The quadratic formula basically doing stuff with the coefficients 1, negative 1, negative 1, and then divide by 2. So x equals 1 plus or minus the square root. This is negative 4, so 1 minus negative 4 is 5 over 2. 1 plus or minus 5 over 2. Quadratic equation always has 2 answers. The first one 1 minus the square root of 5 divided by 2. It's just negative 0.618. The other one, 1 plus the square root of 5 divided by 2. 1.618. And when you do a quadratic equation, you always have to check the answers because sometimes one of them can be erroneous. So check negative 0.618. If you plug that in here, x squared equals x plus 1. So square that. It's 0.382, and then add 1 to it. Add 1 to it, and you get positive 0.382. So
So what is the ratio? 1 to 1.618?
yeah, the ratio is 1.618, which is, you know, an infinite number of possibilities. And one famous example is this is named after somebody, but I don't remember. If you take a rectangle whose ratio of this side to this side is 1.618, and then you draw another rectangle in it whose ratio here to here is 1.618, and then you do it again here, and you do it again here, and here, and here, and here, then that's supposed to be like the exact proportion of a nautilus or something. Like a nautilus's shell, the cross section should end up exactly in line with that. And that's a famous picture. So that's one of the places where they found the
Okay. Are you done? Who discovered phi? Does anybody know? Was it Pythagoras or?
I don't know who discovered phi. I think the Greeks were aware of it because they built a lot of their stuff with that ratio in it.
So it's 1 to 1.6. 1/8. That's
Yeah.
the ratio.
Yeah, that would be one of the possible ratios.
Okay. One of the possible, what do you mean? I thought that was the ratio.
Well, the ratio is 1.618. Which is, you know, an infinite number of combinations can make that ratio.
What do you mean infinite number of combinations can make that ratio?
Like if your ratio is 2, that can be 4 to 2 or 8 to 4.